All right. So what y'all think of the apple trees challenge?
It's pretty fun. It leaves you
room to think about how to implement things. You got to think about how a tree grows.
You're quiet again, Kevin.
Yeah, Joe, we lost you, Kevin.
So I kind of heard, you know, it helps you think about how to try to think about how a tree grows. Is that correct? Yep. All right.
Yeah.
Yep. So yeah. So apple trees challenge is a pretty fun one. Leaves kind of leaves some things up to you to decide on how to implement some certain things, but yeah, let's go ahead and get started. So let's go ahead and fork this over. So I'm going to fork it over to my personal GitHub. It's Tom Preet, OOP Apple Trees. And then we're going to clone that down. All right. Please mute if you're not muted. Thank you. All right. So I'm going to clone this down. Click that copied button. Go over to Papa Challenges, which I'm currently in, and Git clone. All right. If I can list everything out in there, I can see apple trees right here, OOP apple trees. So I can CD into OOP apple trees. And now I'm going to open this up into a new VS Code window. And we'll go ahead and get started. All right. So it looks like we already have some spec files. So looks like we have a apple spec, apple tree runner file, apple tree spec file, apple tree and apple file. So let's first examine the apple. So it looks like we have an apple class, apple tree class. Yep. So again, when you think about like object-oriented programming, if you think of a class as like an actual physical something, like as like an actual physical object, such as like an apple. So an apple tree has many apples. So let's quickly look at here. So summary, reigning Washington grows apples. Fun fact, on average, Washington state grows 125 million boxes of apples per year at 40 pounds per box. That's 2.5 million tons of apples. Let's create a toy program to model an apple tree growing over the years. We plant the apple tree. So I'm thinking we create an instance of an apple tree when we plant it, wait for it to bear some fruit. So maybe after a certain number of years, it starts growing some fruit, and then pick all the apples as soon as it does. So, okay, an apple tree has many apples. The tests in apple tree spec show how this all might work together. So we have several releases, or a few releases. Release 0, implement the apple tree and apple classes. Set up your apple tree and apple classes with the appropriate attributes. You'll need to be able to call tree.height. So tree is an instance of an apple tree, and it has an attribute called height, or an instance variable called height, because each tree height is different. And also tree age. So age is another instance variable that displays the age of the height of the tree. All right. So let's come over here and look at the apple tree spec file. I'm going to split the screens to bring the spec file over here, and we can kind of see what we're kind of testing. So it looks like the apple tree, so test tree age, apple tree, we're creating an instance of an apple tree, apple tree. So right when we create our first instance, the age is 0. So maybe we want to start off with the default value of 0. And when we age the tree, once, it equals 1 year. So it looks like the age tree doesn't take in any variables or any arguments. Okay, cool. Any questions about what we need can kind of do? So All right. Let's see. So it looks like tree height, tree age. Okay, looks like down here. So when we initialize a new apple tree, we can do self dot age. We can initialize it with an initial age of 0 and self dot height. We can initialize the height as a string of 0. I don't know what 0 means. It might be feet, inches. We can also implement like an actual string, like no. But let's just do it as 0. Oh, it looks like here original height is 0. Okay. All right. So implement aging. The age tree instance message should age your tree 1 year. Each year, the tree should get some amount taller and then eventually stop growing. All right. So age tree, the first thing we need to do is age the tree 1 year when we call this. So self dot age plus equals 1. And it should get some amount taller and then eventually stop growing. All right. You can decide when the tree stops growing. So what we can do is, and at what point does this tree stop growing? Does anybody have like a specific height that this tree wants?
So after
I can't hear you. You kind of
You're
went
muted.
out.
keep doing that.
It matures after a certain amount of years.
Did it again.
Yeah, something's auto muting you, Kevin, as soon as you say something.
Yep. So I'm going to just say, after the tree is, as long as the tree is under the age of 100, right? Let's just say if the tree, so self.age is less than 100, do something. So we can increase the height, self.height. Let's just keep it simple for right now. It increases 2 feet every year. Might as well. So as long as the age is less than 100, it increases the height by 2. All right. What else does it say? Oh, later it should die. Oh, that's always fun. If after a certain age, so I can also say else. So if the age is greater than 100, it should die. I'm just looking here. Age tree is a method which ages the tree 1 year and grows the tree a little if it's able to grow. So if it's able to grow. So this right here determines whether or not if it's able to grow. Else, have an is dead method, which returns true if the tree has died. Let's say the tree dies at 100. Else, say if self.age is greater than or equal to 100. Return true. Else false. So this just says if the tree, this is a ternary operator. If the tree is age is greater than 100, it returns true. So that means it's dead, else it's false. Yeah. See what else.
I have a quick question. I ended up making a whole bunch of like instance attributes to kind of store a lot of this stuff.
Yep.
But I didn't require calling of those instant attributes or programming of those instant attributes for the initialization. Is that frowned upon, or is that okay to have like lots of extra instance attributes that you're going to kind of use to track things with?
So your question was, you created a bunch of instance
Yeah, so like
variables.
right there, that's kind of what I was getting at, is I made an
Oh.
instant attribute for is dead
Yeah.
instead of kind of having the logic in the definition of is dead based on age. I just made the instant attribute and then updated the instant attribute.
No,
Okay.
that's definitely good. So I'm going to actually do the same. So I've got this self that is dead. When I first initialize it, create an apple tree, it's not dead. But after it grows to be 100, I'm going to do self dot is dead equals true. And so down here, I can just return self dot is dead, which is a Boolean value determining whether or not it's dead or not. Yeah, I'm going to do that way. And that's totally okay. If you did it the other way, whether it's you just keep track of the age, that's also totally fine. I'm just looking at the test cases simultaneously, but let's go down here. All right. Not taller. So we have age tree. Update your tests, these methods and their side effects. All right. So when I implement create a new instance, let's actually run this. Oh. Python, apple tree spec. All right, let's see. So it looks like it passed the first two and failed and passed the last one. I don't even know what the last one is. So this kind of really doesn't do anything. I mean, it passes it by default, but it's not actually working. When you call the is dead method, it will let you know if the tree is dead. So I add the tree. So when I add the age here, so this one, just to pass the test, this reassigns the age thing. It just automatically updates the attribute. So I guess I could say like, I don't know, what should I do? Should I, in order to test the pet, can I do like
Wouldn't you have
false?
a problem there with naming your that method the same name as that?
Oh, you're right. Yep. So just keep it simple. Yep. Good catch. So is tree dead? Let's get a little more specific. Let's run that. I still get the same. Am I allowed to do inline ternaries?
I think the issue is that you're updating the age straight up.
Yep.
And your is dead method is not checking age, it's checking the value. So that your test case is not calling age tree, it's just modifying it. So you might have to go back to your first option of is dead should be checking the age directly and instead of caching the value from age tree.
Right. I'm gonna just to test the test cases. I'm gonna do like self dot is tree dead equals true and return self dot is tree dead, which is else. Just I guess I could just else and self dot is tree dead. And this is just checking. And if it is over, then I'm actually reassigning it. So I just want to see if this is going to work.
Don't forget line 12.
Line 12.
You still have is dead instead of is tree dead.
Yep. Thank you. clear, run that again. All right. So that one's still failing. What's happening? So if tree.age, is that the third one?
Isn't it effectively killing the tree because it's assigning apple tree age to 500?
Yep.
So
it's
just
kill-
match. Yeah, just match the variable name. No.
But here I'm calling apple tree is tree dead or is dead. And then it should come into this, right? Else. Call that. Why isn't that working? Just want to see if this
Is
is
it
actually.
the self keyword or no?
So if I come up here, it should print it. So it comes here. Assert true. So it's like working.
So it's not self apple tree age equals 500.
Self dot apple tree. No, because
Yeah.
we're creating the instance right in
Oh,
here.
that's right.
No. Is anybody seeing anything totally out of the ordinary?
I was having a similar issue with a tree that was throwing an error on my bear's fruit versus not having fruit, not having fruit. It would run in my spec, in my regular file, but not my spec file.
Or how do we know that is tree dead is actually becoming false when we return it on the else?
So, oh, what did I just do? So the question was, how do I know if it's actually returning true?
Yeah, for the else statement, it's
Yeah.
just holding its old value, which is false. So he could get rid of that else statement altogether and just move his return line up above the if else.
Wait, say that again?
Yeah, that too. Yeah, that too.
Say that one more time?
For
Yeah,
the,
exactly.
yeah, there's that. And then
Oh, yeah.
we don't know, I guess. I don't see where we're making that value. I guess that would be false. Never mind.
It's when he initializes it, it's false. So long as he doesn't change it, it's initialized as false, and it'll retain that until updated. And you don't need the double return down there. You can take the return out of the if statement.
But this
You
part,
just gotta move it up a level now, outside the if statement.
this?
No, at the bottom under right there.
Oh, I see what you mean. Yeah. I mean, it's still gonna fail. Yeah. Anyway.
So what worked on mine was under the def is dead. I just had return self.age greater than 100.
Tom, I
That seemed
think,
to work out well without declaring up at the top self.is tree dead.
Right.
Tom, I think that test case is passing. I'm not sure they execute in order. It looks like getting
Oh.
test any apples is failing and test pick an apple is getting an error. Right, I think you might be passing it.
Oh, crikeys. Okay. All right. That's why path Python, was it fail fast?
Yeah.
There we go. Let's see which ones we're failing. Okay. Yeah. Thank you. Why don't they? I thought they executed it in order.
Yeah, I'm not sure. It might be alphabetical or it might be kind of random order. I forget how they pick which ones they run.
Gotcha. Cool. So that one does pass. Now what is it? Test any apples. So create an apple tree, has any apples. I don't know what iter tools mean, repeat none to 10. So it creates, ages the tree 10 years. Is that correct? I believe. And say that again.
You have no idea why they had the imported inner tools.
Yeah.
It's not needed.
Yeah. So this just repeats it 10 times. So it ages the tree 10 years. And after I age the tree 10 years, it should create apples or, so when I age the tree, I can, create some apples. So when the age is greater than 100 or age is less than 100, I can create some apples. Question is, how many apples should I create? And yeah, so how many apples should I create? So ages, I'm going to create like a random for I in range. I'm going to create a bunch of random apples. Random dot rand. I'm going to create 1 to 10. So it's going to create 1 to 9 apples. So I need to import random. So let's just look at this. Because I don't want to just create 1 apple every year. Print I. I'm just going to say number of
Random dot random.
rand int. I can even get rid of that, and I could say from random import rand int. So number of apples created, I just to see how many apples are created. So these are how many apples are created each time. 1, 2, 3, 4, 5, 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each year, 1, 2, 3, 4, 5, 6, 7, 8, 9 or 8. Cool. So I can create a new apple instance in here. All right, but now where should I store these apple instances? Probably gonna store them up here. Self dot what should I call it? Like all apples, or just call them apples. And in here, it's going to be an array of apple instances. So for I in range, apple equals apple. So I need to import from apple, import apple. Now, if I look at apple, it's right here. So I'm not really doing anything with this apple. I'm just creating an apple instance. There's really no attributes about it, but I can create an apple that way. And now I can self dot apples dot append an apple instance. So if age is less than 100, increases the height by 2 and creates a random integer between 1 and 9 and creates an apple instance for each iteration. So right here, any apples, when I age the tree a certain number of years, so 10 years, it should have apples. And I can test to see if it has apples by saying if return true, if the length of self dot apples is greater than 0, else false. Why is that? There we go. So if I clear that, fail fast. What did it say? Ran 5 tests. All right, so that test passed. So pick an apple. What do you
Hey,
call?
Tom, just a
Yep.
small note, for line 28, can we just return the result of the comparison? I think that might kind of.
The result of the comparison.
Yeah, so it's something we talked about yesterday, but if you just do self, the length that you're checking greater than 0. So we're doing a comparison that's going
Oh,
to
yeah.
return a Boolean value. So again, both ways are correct. It's just that one way is a little more condensed so that, you know, the comparison is going to be your result anyway.
Yep. So this is going to return true or false. So yeah, this is the more optimal way to do it versus a ternary. I just got used to writing ternaries. So I defaulted to the ternary operator, but this will always return a Boolean value, true or false. And this is shorter condenser, and it's a little bit more easier. Yeah. All right. So pick an apple. So apple trees, I can age the tree. Apple tree, pick an apple. Type of apple. Okay. So pick an apple. I can say like, all right. If let's do the comparison operator, if this is true or false. So that means it's true. I can picked apple and do self.apples.pop. So I'm literally popping off an apple from this array of apple instances. And I can just return the picked apple because I need this picked apple. The type of that's being returned should be a apple instance. So if I run that, so I ran all 6 tests, all should be good. Is there any other, what else should I'm doing? Picked an apple. Is there anything that I'm missing with regards to any just basic logic? I mean, there's the test, but I'm just trying to think of a tree. So do like trees automatically start growing apples after 1 year? Probably not. So I could add some like logic in there. So like if the age is between 5 and 80 is when you want to start growing apples on the apple tree. And I can actually create a tree. Let's just, instead of using tests, apple tree, creating apple tree instance, apple tree dot age tree. And now I can just like print apple tree dot apples just to show you kind of the array Python apple tree. So you can kind of see each of one of these is an apple instance, like so. All right, so that's the apple tree. Let's look at some other files. Looks like we have an apple spec file. So test apple diameter. When you create an apple, it will have a diameter greater than 0. All right. So here, maybe I want to create apple diameter. So I can do like self dot diameter equals what do I want to do? I can like create, I can import random again and create a random diameter between, yeah, I'm just trying to think. Random dot rand int between 1 and 4, 1 and 5. So if I wanted to Python apple dot underscore spec. So that test ran. That's good. I can also make sure each apple, so like min size, this is another way, equals 2. Max size equals like 4. Then I can like round, because what if I actually want like it to be in a decimal point? Random dot uniform apple dot min size apple dot max size, and I want to round to 2 integers or 2 decimal points. So here, let's just view print each apple diameter. So you can kind of see.
You had a typo in your apples, huh?
Oh,
With the round function of this and the D.
thank you. So if I clear that, and if I run that apple tree, or let's run that apple spec file, apple tree spec file, just so we can see. So you can kind of see all the different apple diameters in there now. All right. Just one way you can do some random stuff. Some random, give a max size, min size, max size, decimal point. All right, but now we have this runner file. Don't know what this is doing. Let's like read through it. So this apple tree, it's got create an apple tree instance. We're saying while if no apples, then age tree. So while any apples equals false. So if I call, let's actually just bring this over here, get rid of that spec file. So when any apples, so come down here, when any apples, there's a comparison operator, is false, it's going to age the tree. So it's just going to keep on aging the tree. If there's, and it says my apple tree is producing apples at blank age. Okay, so maybe I want to add some other variables in here or attributes or logic in here. Maybe it starts producing apples at age 5, something like that. But in our current logic, it's going to start creating apples at age 2 or age 1. So if I do Python runner, or apple tree runner, so if I come up here, oh geez, probably doesn't go back. Oh, am I still printing that off? Oh man. Where'd it go? Age 1 and is 2 feet tall. Here's the year 1 report. Uh-oh, average diameter of none inches. All right, so while tree is not dead, here's this random apple basket. If it has apples, I can pick a single apple, average diameter, change this so it is calculated average diameter of all apples in the basket. All right, so let's go ahead and create a function to calculate the average diameters in a basket. Get rid of that. I'm going to create a helper method .py file. And this is just going to def get average diameter And this is going to take in. So what is it saying? Change this so it is calculated average diameter of all apples in the basket. So here's the apple basket. So this apple basket is going to take in an array that's going to contain an array of apple instances. So I can say like array of apple instances, and now I can say like, hey, if the length of array of apple instances is greater than 0, total diameter equals 0. I'm just going to create a variable called the total length or total number of apples, which is the length of the array of apple instances. I'm going to say for apple and array of apple instances. So this apple represents an apple instance inside of this apple array. Total diameter plus equals apple dot diameter. Then I can just take the average. I'm sure there's like a built-in method. Total diameter divided by total length. And then I can just return the average. Else, return no remaining apples in apple basket or on tree. Yeah, there we go. I'll just do no remaining apples. All right, so I've got this average diameter. Now let's go ahead and import that inside of this from helper methods, import get average diameter. And then it says change this to get average diameter and pass in the apple basket array. So if I clear that, that should work. Yeah, I mean, it actually did work. So yeah, it's saying while there's apples on the tree, pick an apple from the apple tree, throw it in this basket. So it just keeps picking all apples until there's no apples left by putting them in this basket. And then I'm passing all the apples that I picked from the tree, putting in this get average diameter, which this method just grabs the average diameter of all the apples, assigns it to this variable. I print the tree age, height, the length of the apple basket. So length of apple basket. Harvest, so there's 8 apples with an average diameter of 2.8. And then I just keep aging the tree. And once it hits 100, yeah. Any questions about apple tree? Nope. All right.
You made it look